Welcome back to Key Safety Talks, everyone. I'm excited to be diving into a topic that's so important for anyone working with or even just around hazardous materials.
Mm.
We're talking about those systems we use to classify materials and, really understand the risks they have.
Yeah, it's something that we often just take for granted, those labels on containers, but there's a whole world of science and testing behind them.
Exactly. And we're going to be comparing two key systems today, the Hazard Communication Standard, which a lot of you might know as HCS, and the Globally Harmonized System, or GHS. And GHS, that one's really aimed at creating a consistent standard around the world. And I think you might be surprised at how different these two approaches can be.
Oh, absolutely. Even for something that seems, relatively straightforward, like, let's say, explosives.
Okay, yeah. Explosives. Let's start there. Because I know the HCS, that one's all about simplicity. It puts every single explosive into one category. But when I think about it, like a tiny little firecracker and something that can take out a whole city block, those are both explosives, but the hazard is wildly different, right?
Right, exactly. And that's where the GHS comes in because it gets way more granular, breaking down explosives into 6 divisions based on what kind of hazard they have.
6 divisions. Okay,
Yeah.
so tell me more about these divisions. What kind of hazards are we talking about here?
So, for example, you've got Division 1.1, and that's all about mass explosion hazards. So that's the worst one where the entire load detonates super quickly. Basically, the ones that have a really massive explosion risk.
Oh, wow. So this could level the city block category.
Yeah. Pretty much. And then you have Division 1.2, which covers projection hazards. So it's not necessarily a full detonation, but fragments could be thrown outwards. And then there's Division 1.3, which focuses on fire hazards. So these are things that burn super intensely, maybe cause some little blasts or projections, but the main hazard is fire.
Gotcha. So it's all about breaking down those specifics. So it really helps us understand the nitty-gritty of like what the risk is. So like those fireworks we were talking about before, where do those fit in?
So fireworks would probably be Division 1.4, which is explosives, where the effects are basically contained to the packaging. So they're designed to explode in a controlled way, but more for those visual effects rather than, mass destruction.
That makes sense. So GHS really separates the ooh, pretty from the run for your life kind of thing. Are there even less dangerous explosives, though? I'm curious now.
You would be surprised, yes. So you have divisions 1.5 and 1.6, and those get into what we call very insensitive substances. So 1.5, it's still a mass explosion hazard, but it's really, really difficult to make it ignite. It needs almost the perfect conditions.
Oh, it's like incredibly stable.
Exactly. And then you have 1.6, which is the most stable of them all. They're extremely insensitive articles with a tiny chance of accidental detonation.
This is blowing my mind. I had no idea there were so many levels to classifying explosives. How does the GHS figure out like which division something belongs to?
Well, it's definitely not just guesswork. They actually use 28 different tests, all outlined in something called the UN Manual of Tests and Criteria. And these tests are really rigorous. They look at sensitivity to shock, friction, how stable it is under heat, everything.
28 tests. Wow, they're serious.
Oh, absolutely. They don't mess around. Because the goal is to have no room for guessing, right? Because those classifications, they're super important for safe storage, transport, handling.
It makes you think about those labels in a whole new way. Now, speaking of labels, let's move on to something a little different. Flammable gases. I know even from everyday life that some things that burn, they're a lot riskier than others. Does the GHS go into that kind of detail?
You bet it does. With flammable gases, both HCS and GHS, they've got 2 categories, but the GHS takes it a step further and uses specific testing to figure out what's called the flammability range in air.
Okay, so how easily it catches fire, basically.
Exactly. Category 1, those are gases that can ignite at super low concentrations in the air. We're talking like 13% or less by volume. Like propane, the stuff we use in our grills and for heating, that ignites really easily. So that's a classic Category 1.
Wow, so something as common as the propane in my grill is considered that dangerous?
It is. It just goes to show how important understanding these classifications are. The GHS, it gives us the standardized way to assess these hazards, so it's clearer for everyone. Then you have Category 2, which is basically for flammable gases that don't meet those strict Category 1 criteria.
So again, more specific information so we can make better decisions. What about aerosols, like those cans of spray paint or hairspray? Where do those fit in?
Ah, good question. You're talking about flammable aerosols. And that's another area where both systems, they have 2 categories, but yet again, GHS requires more specific testing.
I'm sensing a bit of a pattern here. More testing equals a more informed classification.
You got it. The GHS, it's all about using those standardized tests so there's no guessing, and we're all understanding these hazards in the same way. It's like having a universal language for safety.
I like that, a universal language for safety. Okay, so we've covered explosions and things that burn. But what about substances that make other things burn? The ones that make fires even worse?
Oh, you mean oxidizing gases? Yeah, these are the ones that can make other things burn, even without air, so they can make fires way more intense.
So like the fire helpers, making things go up in flames even faster.
Exactly, and this is where you see a big difference between HCS and GHS. HCS, it puts all oxidizing gases into one big category, but the GHS, it gets specific and requires testing, based on international standards, to see how easily something contributes to combustion.
Okay, so even though there's just one category, that testing requirement, it makes a huge difference. It seems like that's a theme here.
It definitely is. Because it's not just about whether or not there's a hazard, but understanding how bad that hazard is, and that's where the GHS really stands out.
Gotcha. Okay, I'm really starting to see how this level of detail could be life or death in some situations. Now, what about those pressurized containers? Just thinking about one failing, it makes me nervous.
It's definitely a hazard, and this is where you see the GHS really taking a different path than HCS. So HCS, they just have one category for all gases under pressure. But the GHS, they get much more specific.
How specific are we talking?
They actually have 4 categories based on whether the gas is liquefied, compressed, dissolved in a solvent, or something else.
Wow, 4 categories. That's a level of detail I never would have imagined.
It might seem like a lot, but each of those categories, it means a different type of hazard. Like a liquefied gas under pressure, it's not going to behave the same way as a compressed gas. And knowing that, it's so important for safety, right? For how you handle it, where you store it.
Okay, yeah.
Yeah.
You're really making me see those labels on containers in a whole new light.
Yeah.
So let's move on to flammable liquids. Everything from gasoline to even like nail polish remover.
Yeah.
How does GHS approach these?
So this is where things get pretty interesting. HECS, they keep it simple with 2 categories based on what's called the flash point, which is basically the temperature where a liquid can vaporize and ignite.
So basically how easily it catches fire.
You got it.
Right.
Now, GHS, they take it a step further. They divide flammable liquids into 4 categories. They don't just look at the flash point, but also the boiling point. It's like double checking for flammability, an extra layer of safety.
So it's not just will it burn, it's how easily and at what temperature will it burn.
Exactly. And get this, they even get super specific and say what kind of closed cup test has to be used to figure out that flash point. So it's all about having a standardized approach, right? Making sure everyone's on the same page.
Wow, they really are taking this seriously.
Absolutely, as they should. It's all about protecting people and preventing accidents.
It's really making me think about how much goes into something as simple as a label. Now, I have to admit, I hadn't really thought about solids as being a major fire hazard.
Yeah.
What about those?
Oh, that's a common misconception. Some solids can be super dangerous when it comes to fire. HCS, it acknowledges that with a single category, but GHS, they dig a little deeper and divide flammable solids into 2 categories based on their burning rate.
So like some catch fire quicker and burn faster than others.
Exactly. And we're talking about a whole range of solids here, from wood and paper to some chemicals and even metal powders, believe it or not.
Metal powders. Now that is surprising. I would have thought they'd go up in flames in a second.
It's a good reminder that just because something burns intensely, it doesn't always mean it's the most dangerous. Sometimes a slow, steady burn can cause just as much destruction as a quick flash.
Makes sense. Have there been any major accidents because of flammable solids being mishandled?
Sadly, yes. Back in 2008, there was a sugar dust explosion at a refinery in Georgia. It was a horrible accident that killed 14 people and injured many others. It just goes to show that even something that seems harmless, like sugar dust, can be incredibly dangerous if it's not handled correctly.
Wow, that's a sobering reminder that these classifications, they're not just labels, they're about people's lives.
Yeah.
Okay, let's move on to something that sounds a bit more like a sci-fi movie. Self-reactive substances. What are those?
So these are substances that can decompose and release a lot of heat, even without oxygen. It's called exothermic decomposition.
So they can basically like combust all on their own.
You got it. And while HCS just lumps them all into one category, GHS divides them into 7 types labeled A through G based on how likely they are to explode or decompose without oxygen.
7 types. Okay, so we're talking about a whole range of reactivity here.
Exactly. You have type A, which are the most reactive. These are the ones that could potentially detonate or, deflagrate really quickly, even when they're still in their packaging. It's like having a tiny explosion just waiting to happen.
That sounds incredibly dangerous.
It can be, which is why that classification is so important, so people know how to handle it safely. Then you have type B substances. They also have explosive properties, but they're less likely to detonate or deflagrate so fast. They're more likely to have what's called a thermal explosion, where the heat builds up inside really quickly, and then boom, you have a sudden release of energy.
Okay, so still a huge hazard,
Yeah.
but maybe a bit more predictable. What about those other types?
So type C through G, they basically go down in reactivity. As you go further down the alphabet, they get less and less reactive. Type G is the least reactive of them all.
So it's like a spectrum of, okay, how reactive is this thing? And that's what the categories tell us.
Exactly. And to figure out where a substance falls on that spectrum, the GHS uses a bunch of tests. They're outlined in the UN Manual of Tests and Criteria Part 2, and they look at things like how sensitive it is to impact, heat, friction, to get the full picture of how reactive it is.
It's fascinating that there's a whole world of complexity even within a category like self-reactive substances.
There really is. And the GHS provides a framework for understanding that complexity, so we're not just lumping everything together and calling it a day.
It's like having a map with all the little side streets and alleys instead of just knowing the general direction.
Exactly.
Okay, now this next category sounds pretty intimidating. Pyrophoric substances. What are we talking about here?
Oh, it's not as complicated as it sounds. Pyrophoric substances are basically anything that can ignite spontaneously in air, and it can be a liquid or a solid.
Wait, spontaneously, just from contact with air.
Yep, that's it. And the GHS, they have a very specific rule for this. It has to ignite within 5 minutes of being exposed to air to be classified as pyrophoric.
So if you're working with something that's classified as pyrophoric, you have to be incredibly careful.
You do. Because even a small delay in handling them can have really bad consequences.
Have there been any accidents, like in the real world, that show how dangerous pyrophoric substances can be?
Unfortunately, yes. There was a tragic accident in Texas in 2014. A worker was handling a pyrophoric chemical, and there was a delay in getting the proper safety equipment. The chemical ignited, and there was a fire, and the worker, he sadly lost his life.
Oh, that's awful. It just goes to show how important it is to understand these classifications and have the right safety procedures in place.
I couldn't agree more. And even though both the HCS and GHS have one category for pyrophoric substances, the GHS, they use specific tests from the UN manual to be sure something is actually pyrophoric. It's all about taking the guesswork out of it.
Okay, so again, more specific testing equals a better understanding of the hazard. Now, you mentioned earlier that the HCS is simpler than the GHS. Are there any hazards that HCS doesn't even have a category for?
You're right. The HCS takes a broader approach, so it misses a few things. One example is self-heating substances.
Self-heating substances, you mean the HCS doesn't even mention those?
Nope. But the GHS, they recognize that these can be dangerous, and they have a dedicated category for them. And of course, they have tests to see how easily a substance can heat up on its own.
So what exactly are self-heating substances, and why are they a concern?
Imagine a substance that can get so hot that it ignites all on its own without any help from an outside heat source. That's what self-heating substances can do. It's all because of internal chemical reactions that make heat.
So it's like they have a built-in risk of spontaneous combustion, kind of like those pyrophorics we talked about.
It's similar, but the trigger is different. Pyrophorics, it's contact with air that sets them off. With self-heating substances, it's all about that internal chemical reaction making heat.
Okay, so two different paths to the same dangerous outcome. So how does the GHS test for that?
They use a test that looks at how easily it heats up in different sizes. It helps us understand the risks and how we need to store them safely so they don't start a fire.
Makes sense. So a very specific and thorough approach to classifying these hazards.
Yeah.
Now, what about those substances that, like, you can't just throw water on them if they catch fire because they react badly with water?
Ah, yes. Those are substances that release flammable gases when they come into contact with water. I know it sounds a bit counterintuitive, right? Water's supposed to put out fires, not make them worse. But you'd be surprised how many substances react violently with water, creating even more flammable stuff.
Oh, that sounds like a disaster waiting to happen. So how do HCS and GHS deal with that?
No surprise here, HCS just has one category. But the GHS, they divide them into 3 categories based on how quickly that flammable gas is released.
So some reactions are more violent and faster than others.
You got it. Category 1, those have the fastest reaction rate. They produce a ton of flammable gas super quickly. Category 2 substances, they react a bit slower. And then category 3, they're still reactive, but they don't meet the criteria for the first two categories.
And I bet GHS has specific tests for this too, right?
Of course they do. They use a test that looks at how fast the flammable gas is being released, so we know how fast and intense that reaction is going to be.
It's amazing to me how much thought and science goes into classifying these hazards. Have there been any, like, real-world incidents that show how dangerous these substances can be?
Unfortunately, there have been. Back in 1986, there was a big chemical spill in Switzerland into the Rhine River. One of the chemicals that spilled, it reacted super violently with water, producing a bunch of toxic and flammable gases. It was a huge disaster. Killed tons of fish, messed up the drinking water for hundreds of thousands of people.
Wow, that's a scary reminder of what can happen if these substances aren't handled properly. And it really highlights the need for everyone to be on the same page using systems like the GHS. Now, let's talk about oxidizing liquids and solids. Are those the ones that don't necessarily burn themselves, but can make other things burn more easily?
You got it. Think of them as the enablers of combustion.
Okay, so they make a fire worse, but they don't start it themselves.
Exactly. And you know the drill by now. HCS keeps it simple with just one category for both liquids and solids. But the GHS, they split them up into 3 categories each and have specific tests to figure out how easily they can make other things ignite and burn.
So even with something like oxidizing agents, there's different levels of how dangerous they are. What would be like a classic example of a strong oxidizing liquid?
Good question. Concentrated nitric acid is a good example. It's super corrosive, and if it touches anything flammable, whoosh, you could have a huge fire.
Definitely not something you want to mess around with. Okay, I think we saved the most dramatic category for last. Organic peroxides. Why are those so hazardous?
So organic peroxides, they have a special kind of oxygen bond, and that makes them really, really reactive, and often they can explode.
So we're talking about a whole other level of hazard here.
Absolutely. Organic peroxides are notorious for decomposing violently, leading to fires and explosions. And as you probably guessed, HCS has just one category, while the GHS, they go all out.
How many categories are we talking about for organic peroxides?
7. They've got 7 different categories, which reflects just how many different kinds of hazards they can pose.
7. Wow, that's the most we've seen so far for any category. They must be a really diverse group.
They are, and just like those self-reactive substances we talked about, the GHS uses 8 different tests from the UN manual to classify them. Those tests look at everything from how stable they are under heat to how sensitive they are to impact and friction.
So a lot of science goes into figuring out those categories.
Yeah. Oh, tons. Because it's not about guessing, it's about having a rigorous system to keep people safe.
And I'm assuming there have been incidents that show why this is so important.
You bet. Back in 1991, there's a terrible explosion at a chemical plant in Spain. It turned out that it was caused by mishandling organic peroxides. There was a lot of damage, and several people, they sadly lost their lives.
It just shows how important these classifications are and why having strict safety rules for handling these substances is so important. It's been really eye-opening to see just how much work goes into understanding and categorizing these hazards, you know.
It really is a never-ending process of research and testing and making sure we're doing everything we can to protect people.
Well, I think we've covered a lot of ground here, from explosives all the way to organic peroxides, and I'm really starting to see that key difference between HCS and GHS.
What's standing out to you the most?
It's definitely the level of detail. HCS, it's like a basic overview. While GHS, it really gets down to the nitty-gritty. It's got more categories, more testing, and it's so focused on understanding those little differences in each hazard. It's like the difference between looking at a regular map and then zooming in on a satellite image. You know, it gets so much more information.
That's a great analogy, and that level of detail is what makes all the difference when it comes to safety, because then we know exactly what we need to do to protect ourselves, you know?
It makes perfect sense. I feel like I'm looking at those labels on containers in a whole new way. But, and I think this is really important, this is just the beginning, right? We still need to look at the bigger picture. Like, why is the GHS so important in a globalized world where things are moving back and forth all the time?
That's a great point. That's where things get really interesting. It really is.
What?
Imagine for a second a world where each country had its own system for classifying hazardous materials. It would be a mess. Like trying to ship chemicals from one country to another would be a nightmare. No one would be on the same page.
Yeah. Sounds like a recipe for disaster for sure.
Exactly. And that's where the GHS really shines, you know? It's like it creates this common language for everyone, so we're all on the same page when it comes to safety. That's super important for protecting workers, the public, the environment. And it doesn't matter where in the world those materials are being used.
So the GHS is like a safety net for the whole globe, making sure everyone is playing by the same rules.
That's a great way to put it. It really shows you what we can do when we work together and agree on something as important as safety, on an international level.
It is pretty reassuring to know that there's a system like that in place. But I have to admit, I'm thinking about all those categories, all those tests. It seems like GHS could be a lot to handle, especially for someone who's used to that simpler HCS system.
Oh, I hear you. It can definitely feel overwhelming. There's a learning curve, for sure. But the good news is there are tons of resources out there to help people get up to speed on the GHS.
Like what kind of resources?
Well, you can find all sorts of things online, like databases, training courses, even guidance documents from organizations like the UN and OSHA here in the US.
So there's help out there if you need it.
Oh, yeah, absolutely. Tons of it.
That's good to know. Okay, so is the GHS like a one-size-fits-all system? Or can it be, adjusted a bit for different countries or industries?
That's actually one of the best things about the GHS. It's flexible. So different countries and regions, they can tweak things a bit to fit their specific needs, but those core principles, they always stay the same.
Oh, that's smart. Like a framework that can be customized but still, keeps that main structure.
Exactly.
You've mentioned standardized testing a few times now. Can you walk me through an example of how that works, like how a test actually determines a GHS classification?
Sure. Let's go back to those flammable liquids for a second. Remember how we talked about how the GHS uses both the flash point and the boiling point?
Yeah, yeah.
So to figure out the flash point, they usually use something called a closed cup test.
So they literally see how easily it catches fire.
Yep, pretty much. They heat the liquid in a closed container, and then they introduce a tiny flame at different temperatures. The flash point is that lowest temperature where the vapor from the liquid ignites.
So it's not just will it burn, it's how easily and at what temperature.
You got it. And then the boiling point, that's also important, and that's figured out by finding the temperature where the liquid turns into a gas. So by looking at both of those things, the GHS gives us a much better picture of the flammability hazards, more than just a yes or no.
It's really kind of cool to think that all that info is packed into those little symbols and numbers on a container.
It's like its own secret language of safety. And each little thing, those pictograms, those hazard statements, those signal words, they all come from that whole process of testing and classification.
And learning that language, that's what keeps people safe when they're working with these materials.
Okay, we've talked a lot about the specifics of the GHS, how it compares to HCS, but stepping back for a second, why do you think it's so important to have these internationally agreed upon systems for classifying hazardous materials? Like, what's the big picture here?
That's a great question. I think it really comes down to three main things: safety, trade, and protecting the environment. So first, when everyone understands the hazards the same way, then we can have the same safety procedures, the same training programs around the world.
Like having one set of instructions that works no matter where you are.
Exactly. And that protects workers, emergency responders, everyone from getting hurt. Then you have the trade aspect. Think about trying to, import or export chemicals. If every single country has its own rules, its own classification system, it would be a nightmare.
So not just inefficient, but dangerous. You got it. The GHS, it helps make sure everyone's on the same page, so there's less confusion, fewer delays, and fewer risks because of miscommunication. And then finally, the environment. The GHS is crucial for protecting the environment. If we know exactly what we're dealing with, if we're labeling things correctly, then we can manage those materials better. How we transport them, store them, dispose of them. And that means fewer spills, fewer leaks, fewer accidents that could hurt the environment.
So it's a win-win for everyone and everything.
Exactly. A safer, more sustainable world where we're all connected.
You mentioned earlier that there are all those resources out there for people who want to learn more about the GHS. Can you give our listeners some specific places where they can find that information?
Of course. One of the best places to start is the United Nations website for the GHS. They've got a ton of info, like the whole text of the GHS, Purple Book, guidance documents, training stuff, FAQs, you name it.
Okay, straight from the source. Anything else?
OSHA's website is another good one. OSHA's the one who adopted the GHS for the hazard communication standard here in the US, and they have a lot of really helpful, easy to understand information on how to follow the rules. And if you're looking for, more specific training or help, there are tons of private organizations and consultants who can help you out. Just do a quick search online.
That's super helpful. So listeners, if you're feeling a little lost with all this, don't worry. There's help out there.
Totally. And it's worth taking the time to learn this stuff. It might seem technical, but knowing this can really make a difference.
It's about protecting yourselves, the people you work with, the environment. Okay, I want to shift gears a bit. We've been really focused on all those technical details, but even with the best systems, accidents can still happen, right? Especially if people aren't properly trained or don't have the right equipment.
Oh, that's such an important point. It's not enough to just have the systems in place. We need to make sure everyone gets it. They understand the risks, they follow the rules, and they feel like they can speak up if they see something unsafe.
So going beyond just checking the boxes, we need to make safety a part of the culture.
Exactly. We need to encourage people to talk to each other, give them the training they need, and make sure everyone feels comfortable asking questions and raising concerns. Like, if you see something, say something.
So it's a mix of knowledge, being aware, and everyone taking responsibility.
That's a great way to put it. It's about building that safety culture from the ground up.
This has been a really great look into the world of hazard classification.
Yeah.
We talked about those differences between HCS and GHS, that standardized testing, and why it's so important to have this one system that the whole world uses to talk about these materials.
It's been fun unpacking all this with you.
Same here. Okay, before we wrap up, I want to leave our listeners with something to think about. We've talked about how important it is to classify these hazardous materials based on, what they're made of, their properties. But what about the human element? How do we make sure people are trained the right way, that they have the right equipment to handle these materials, not just on paper, but in real life? What role does the workplace culture play in all of this? I'm really curious to hear what you think about all that.
That's a really great question. I think it all starts with the leadership. If safety is truly important, it has to be part of everything the organization does. It can't just be an afterthought.
So making safety a way of life at work, not just a bunch of rules.
Exactly. It's about making people feel like they can and should prioritize safety, not just for themselves, but for their coworkers too.
Safety is everyone's responsibility.
Yeah.
This has been such an eye-opening conversation. I feel like I have a much better understanding of how important hazard classification is and how complex it really is.
I'm glad to hear that.
And listeners, we hope you found this episode helpful and interesting. If you want to hear more deep dives into the world of safety, be sure to subscribe to our YouTube channel.
And remember, knowledge is power when it comes to safety. So stay curious, stay informed, and stay safe out there.
We'll see you on the next episode of Key Safety Talks. So as we're wrapping up this look at HCS versus GHS, I'm really struck by how much work goes into making sure we can work safely with all these, hazardous materials.
It really is its own whole world, and it's always changing as we learn more about these materials and what the risks are.
We've talked about a lot of specifics, but can we sort of boil it all down, the key differences between HCS and GHS into some main takeaways for our listeners?
Absolutely. I think the biggest thing is just how much more specific the GHS is. It has more categories, the criteria are more detailed, and the tests are more standardized, so you end up with a much clearer understanding of what the risks really are.
It's like going from, I don't know, a blurry photo to a high-def image. You get so much more information.
Exactly. And that information, that's what lets us make good decisions about safety, right? How to handle these materials, what precautions to take, how to store them, everything.
The other big takeaway for me is, how global the GHS is. It's not just about one country. It's a whole world effort to get everyone speaking the same language when it comes to safety.
That's so important these days. Everything's moving all over the place. Can you imagine the chaos if each country had its own system?
It wouldn't just be inefficient. It would be really dangerous, I think.
Exactly. GHS makes sure that there's at least a basic level of safety and understanding no matter where you are. It really shows you what can happen when countries work together towards the same goal.
It's pretty inspiring when you think about it that way. Now, we focused a lot on the technical stuff, all the categories and tests and rules.
Yeah.
But at the end of the day, this is all about people, right?
Right, 100%. You can have the best systems in the world, but if people aren't trained well, if they don't know what they're doing, those systems, well, they don't really mean much.
So how do we bridge that gap? How do we make sure that safety isn't just about following the rules, but it's really built into the culture of how we work?
Well, I think education's a big part of it. We need to make sure people understand why things are done a certain way, not just what the rules are. Why do we have to follow this specific procedure? Why is this material in this category? When people understand the reasons, they're more likely to take it seriously and be more careful.
It's about giving them the power to make good choices, not just telling them what to do.
Exactly. And it's about creating an environment where people feel comfortable asking questions, speaking up if they see something that's not safe. If you see something, say something.
It's about good communication, strong leadership, and everyone in the organization taking safety seriously.
That's the recipe for success. When you have all of that, safety becomes more than just a set of rules. It's a value that everyone shares.
Well said. We've covered so much ground in this episode, from the tiniest details of hazard classification to why having this global system is so important. And we talked about how important that human element is.
It's been great to really dig into all of this with you.
Same here. And to our listeners, we hope this has been helpful and interesting. If you want to learn more about safety and hear more discussions like this, be sure to subscribe to our YouTube channel.
And remember, knowing more about safety makes all the difference. So stay curious, keep learning, and stay safe.
And that's a wrap on this episode of Key Safety Talks. We'll see you next time.